Chapter 1, Lesson 1.2. 1.2 has 4 parts, and we're in Part 1. We're given a function, and the function happens to already be in vertex form. The question is what is vertex form? I have it written over here to the right. Vertex form is y equals a times the difference of x minus h all squared plus k. Now, before we move forward, let's go ahead and identify some things that we know. We know that the vertex will be the point hk. So we can look at our vertex form, and whatever our h value is, and whatever our k value is, that will give us the vertex. The next thing is that our axis of symmetry the x value will equal h. So we can look at our h value. Whatever the h value is, that is the x for our axis of symmetry. And if we want to find that exact point, we can plug the x back into our function, solve it for y, and we've created that ordered pair. Then we can look at our a. That will tell us what kind of parabola it is. Is it an upward or a downward parabola? So just from vertex form, we can find these things right here. Let's go ahead and jump into our function. I think the first thing that we need to do is we need to identify all of our values, a, h, and k. Our a value is -1/4. So right off the bat, we know that -1/4 is less than 0, so we're going to have a downward pointing parabola. Our next thing that we identify is our h value. And our h value in this particular point is -2. Keep in mind that vertex form is minus h. But in our example, it says +2. How would we make +2 into a minus? We would have to go minus a -2. That is why the h value is -2. And lastly, our k value is 5. So we've identified important data from vertex form. Step 2. Let's go ahead and plot out the vertex. Let me use green for my Cartesian plane. And you guys at home can do a quick graph with me. I like to try to have about 10 increments. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For most problems that we work, 10 increments either way on the Cartesian plane will be sufficient. All right, so we want to go ahead and plot the vertex. It's important to note, what is the vertex? The vertex is the point hk. We know that our h is -2. And we know that the k is 5. Therefore, we know how to plot the vertex. The vertex is -2, 5. So we go -2 and up. Our vertex is somewhere in that vicinity. And we know it's going to be a downward pointing parabola. Okay? The next thing that we need to do is we need to draw the axis of symmetry. What is the axis of symmetry? The axis of symmetry is the point h, -2. So we know that our axis of symmetry is going to go through the value x equals negative 2. To the best of my ability, I will draw that axis of symmetry, going through the point x negative 2. Now, we want to find, that is the axis of symmetry. The next thing that we want to do is we want to evaluate for 2 more points. Okay? So right over here, I'll use, let's say, ready this time. I'm going to allow my x value to be 0, and I'm going to allow my x value to be 2. Okay? 0 is on that side, and 2 is on that side. All right, let's put it back in. The original function, y equals negative 1/4, 0 plus 2 squared plus 5. And we can solve that using the calculator. All right, 0 plus 2 is 2. 2 squared is 4. 4 times negative 1/4 is negative 1. So we have negative 1 plus 5. So our y value is 4. So what we did was we picked another point, x equals 0, plugged it into that function, did the computation. Now we have 0, 4. Bingo. Our second value that we chose was x equals 2. Remember to pick smart values, and we'll talk a lot about that in class. That's y equals negative 1/4, 2 plus 2, all squared, plus 5. 2 plus 2 is 4. 4 squared is 16. That 16 times negative 1/4 should be negative 4 plus 5. That's y equals 1. So the last point I have is y equals 1. 2, 1. Now, I can go ahead and I can plot 0, 4. Got it? I plotted 0, 4. Now I'm going to plot 2, 1. And we've got a little problem here. We've only got 2 points on the right side of the axis of symmetry. That's right. We can use the reflection of each of these black points on my side of the axis of symmetry. So we have to do a little bit of thinking. How many units away is this point from the axis of symmetry? It's 2. So I'm going to go 2 units here. And I'm going to go up 4 units here. So there's a reflection of that point. I plotted this point, and then I did the reflection of that point. Now I've got to think, how many units is this black point from the axis of symmetry? That's right, it's 4 units away, and then it's up 1 on the y. So it's 1, 2, 3, 4 on my side of the axis of symmetry, and it's up 1. From there, I can now draw my parabola. And it looks something like that. Notice I missed a point there. No big deal. On our quick graph. Quick review. We started vertex form. Vertex form is y equals a times the difference of x minus h all squared plus k. We know some things. The vertex is hk. Axis of symmetry is the h value. And then we can look at the a for is it upward or a downward pointing parabola. We identified our vertex. Our vertex was negative 2, 5. Bam. We identified the axis of symmetry. It runs through x equals negative 2. Bam. The blue dotted line. From there we said let's pick 2 more points. We picked x equals 0 and x equals 2. We plugged into the original function to complete our ordered pairs. 0, 4 was right here. And then 2, 1 was right here. We had to use our thinking. How are we going to create points on this side? Yeah, we could have plugged in a -3 or a -10. We could have done that. But it makes better sense to say, hey, let me reflect this point across my y-axis. Excuse me, my axis of symmetry. Let me reflect this point across my axis of symmetry. That is the first part, graphing a function that is in vertex form.